Hi and welcome to section 2. In this section, we'll set up Docker, look at some of its basic commands, build an image using Dockerfile, and push it to the Docker Hub and ACR. As we've already seen about DevOps and what it consists of, let's now focus on one of its important aspects, which is Docker Container. In this video, we will focus on Docker containers and how to install and configure Docker on Azure Virtual Machine. What are containers? Container technology allows us to create an isolated block of resources within a machine, virtual or otherwise, and share the underlying machine resources without bleeding into other services that are using the same resources. So in effect, it's like a shared server, but without the side effect of one installed system having unintended control over another due to bad resource management, perhaps. A major benefit of a container is that you can specify particular versions of system-level dependencies. Let's say, for example, your system needed a particular version of a DLL or other installable library, but the problem is it's custom or even older, out-of-date version of that particular dependency, and it's not compatible with other processes that share that resource on the virtual machine. With containers, you can isolate dependencies like this and keep them effectively firewalled from one another. The added benefit of this is that if something works on your machine, well then you can take a snapshot of this configuration and transport it to an online host or other developer's machine where it will simply work, no questions asked. This is an incredibly powerful feature of containers and helps them become an integral part of our DevOps toolchain. The most popular container technology at the moment is Docker. Docker gives us all the benefits just outlined and works on both Windows and Linux. Where Docker differs from virtual machines is that virtual machines are full-blown virtual operating system environments, and we need to spin up a full operating system for each service that needs it. That's quite wasteful and not optimal on resources, of course. Docker containers allow us to trim things right back to the bare minimum we need and no more. Let's look at how to set up Docker on a Linux machine. For this example, we will create a virtual machine in Azure and then install Docker inside it. To create a Linux virtual machine, open the Azure portal, and after you click Create a Resource, click the Ubuntu Server option. Fill in the basic details required to create and start the machine. For this example, you can accept all of the defaults the creation wizard provides. The only thing you will need to change is to provide it with an SSH key. An SSH key allows us to make a secure connection. To get one, you're going to either need to copy an existing one or to generate a new one. The key that we will get will be pasted into the SSH memo field, and the SSH username we want will go into the user field. So, let's check if an SSH file is already generated. To do this, we will use the ls command to list the contents of the user SSH folder. If we get an error, or the command returns no results, then we know we have no SSH file ready and we need to generate it. To generate the file, we need to have admin permissions. The safest way to do this is to use the sudo command. The full command is sudo ssh keygen. The keygen will bring you through some steps. You can just accept all of the defaults, but ensure you give it a good strong passphrase. That's really important. The file we're concerned with is the id_rsa.pub file. And if you're lucky, you might also see a nice piece of ASCII generated art. The next step is to get the key value into our clipboard so we can paste it into the Azure portal. We do this by displaying the contents of the file using the cat command. Finally, we want to highlight, select, and copy the contents of the file shown so we can paste it into the Azure portal. Back on the Azure portal now to finish, and we can paste the SSH key we copied from the SSH public key control, and then click on Review and Create, and accept the remaining defaults and let the machine be submitted for creation. When we create the machine, by default it is sitting in a private virtual network, hidden from the internet. To gain access from our workstation, we need to create a network access rule to open a port that points to the machine. To add a rule, select the networking link from the machine settings page, then click on Add Inbound Port link. A new section will open, and in here, select the Basic button. This gives us a simplified interface with preset configurations. Here we select SSH as the service command, give it a name, and save it. When this process completes, we should have a working connection to our machine from the internet. Once the Azure portal indicates the machine has been created, we need to connect to it. Go into the resource panel and at the top, select the Connect button. As this is a Linux machine with no graphic interface, we will connect to it using SSH in a console window. If you click on the icon beside the SSH control, the connection string for logon is shown. Click on the blue clipboard icon to the right to copy this. Back now in our Bash console, we can then paste the login command, enter our password, and we're connected. The final step is to install Docker itself on the machine. The first thing we need to do is add the GNU Privacy Guard or GPG key to the local repository by using the curl command to download it. Curl will give us an OK confirmation when it has completed. Next, we will add the Docker repository to the apt package manager source library. After that, we need to update our system modules using apt-get. Finally, we will install Docker itself using apt manager. Before we wrap up with the install process, we can check that everything went okay and Docker is running by querying its status in the system.